Good day, dear students. Welcome to our video lesson. I am your teacher, Christine, and today we're going to learn about earthquake hazards. But before that, let's first identify what is earthquake and what is hazard. The great Albert Einstein once said that the trouble with people's memories is that it is too short compared with the return periods of disaster like earthquakes. An earthquake is a weak to violent shaking of the ground produced by the sudden movements of rock materials below the Earth's surface. Earthquake can strike suddenly and without warning. Earthquakes can result in the ground shaking, soil liquefaction, landslide, fissures, avalanche, fires, and tsunamis. We should all know that earthquakes suddenly strike anywhere like a proverbial thief in the night. Safety from earthquakes requires constant preparedness even long before potential disastrous events occur. And hazards is a dangerous phenomenon substance, human activity or condition that may cause loss of life, injury or other health impacts, property damage, loss of livelihoods and services, social and economic disruption, or environmental damage. So now that we know what is earthquake and hazards, let's know the definition of earthquake hazards. Earthquake hazards may be experienced depending on the strength of the seismic activity. Factors such as topographic and built features of infrastructures, geologic subsurface, and groundwater. Now, I'm going to discuss the different earthquake hazards. There are 5 different earthquake hazards that I'm going to discuss. First is the ground shaking. Ground shaking is simply the vibration that we feel when the energy built up by application of stress to the lithosphere is released by faulting during an earthquake. Second is the ground rupture. This is another important effect of earthquakes that occurs when the earthquake movements along a fault breaks the Earth's surface.
Hello there, this is Ate Bea and I will assist Teacher Christine to explain what happens each hazard that is being mentioned. Typically, you will feel more intense shaking from a big earthquake than from a small one. Bigger earthquakes also release their energy over a large area and for a longer period of time. An earthquake begins at the hypocenter, and from there, the rupture front travels along the fault, producing waves all the time it is moving. Every point crossed by the rupture front gives off shaking, so longer faults produce bigger earthquakes that have longer durations.
Second is the ground rupture. This is another important effect of earthquakes that occurs when the earthquake movements along a fault breaks the Earth's surface.
In seismology, surface rupture is the visible offset of the ground surface when an earthquake rupture along a fault affects the Earth's surface. Surface rupture is opposed by buried rupture, where there is no replacement at ground level. This is a major risk to any structure that is built across a fault zone that may be active, in addition to any risk from ground shaking.
Third is the liquefaction. Liquefaction is when sediments grain are made to fall in groundwater, which causes the soil to lose all its solidity.
The shaking rearranges sand and slate grains in wet soil underground and the water between the grains is squeezed. Pressure builds up until the grains float and the water is forced up to the surface through the easiest path it can find, often through cracks in the ground or concrete. The rising water takes silt and sand with it, forming sand boils. The ground surface of a liquefied soil often tilts and sinks, damaging buildings, roads, pipes, and tanks. Liquefaction usually only happens in susceptible soils in moderate to strong ground shaking.
Fourth is the earth-induced landslide. This is the ground shaking due to earthquakes destabilize cliffs and steep slopes, causing landslide and rock falls as a significant side effect.
Here is an example of an earthquake-induced landslide. This footage was taken at Nepal in the year 2015.
Lastly is the tsunami. These are destructive waves that are generated by earthquakes and other events have been given numerous misleading names in the past.
Tsunamis can be generated by earthquakes on normal, rivers, and strike-slip faults, but most tsunamis and the largest results from earthquakes on reverse faults. These tsunami-generating earthquakes originate mainly in subduction zones where tectonic plates collide and one is forced under the other. If big enough and close enough to the ocean floor, the energy from such an earthquake can cause the ocean floor to suddenly rise. This sudden vertical displacement of the ocean floor is what typically sets a tsunami in motion.
That's all. Thank you for watching.